So our presentation is on green roofs and their vast benefits. It's by Bailey, Lisa, Stephen, and myself. So let's get to it. A green roof is a living landscape constructed on top of a building to make use of an otherwise barren rooftop. Green roofs are made up of multiple layers of membranes, growing media, hardscape materials, and living plants. Green roofs are highly variable and can range from simple, lightweight designs to complex and weighty designs. Uses for green roofs can vary, from use as public or private leisure areas, restoration of wildlife habitat, or added green space for urban farming. Green roofs can be highly beneficial to urban areas, aiding in stormwater management, reducing the urban heat island effect, and improvement of the well-being of urban residents. In many parts of the world, green roofs are an established industry, while in North America, urban green roofs are rapidly growing in popularity. Green roofs are a landscape feature that were used by many cultures around the world dating back thousands of years. The most famous green roof in history would have to be the Hanging Gardens of Babylon. Not much is known about this wonder of the world, but it was thought to be an incredible feat of engineering for its day, with a wide selection of trees, shrubs, and vines growing on top of an expanse of tiered gardens. The process of building these gardens would have to be extremely difficult and expensive in its day, which is why gardens such as these are so uncommon. For average people of the past, the growing of green roofs served a very different purpose than the opulent gardens of Babylon. Traditionally, green roofs were used to control heat in the summer and insulate buildings in the winter. Sod roofs were very commonly used in Nordic countries, such as Scandinavia, that had seasons of cold and wet weather. Typically, this type of green roof was constructed by adding a thick layer of birch bark with a layer of sod over top to hold down the bark, making the building more watertight while also adding insulation. Another kind of green roof commonly used in Canada would be soddies or sod houses. These structures were used by early settlers in Canada as a fast and inexpensive way of building shelter in a new and unforgiving land. Built from grass and soil held together by roots, these houses were much more utilitarian than modern green roofs. Nevertheless, the ingenuity of using plant material to increase our level of comfort is a lesson we can apply to the buildings of modern green roofs. Green roofs of today. So green roofs have made many advancements in the last 10 to 20 years. Modern solutions make green roofs possible for almost any structure, whether it be in an existing building or integrated into the design of a new build. Green roofs are also no longer solely utilitarian in function, but rather have both practical and aesthetic elements in their design. With modern technology, green roofs have more complex designs and can use a wider variety of plants, which allows the space to be both beautiful while also serving a very practical purpose. Green roofs provide a multitude of advantages, in addition to the benefits provided by their historical counterparts. While they continue to be used for insulation, like the sod roofs of the past, green roofs today serve a much greater purpose, and their benefits range from decreasing building maintenance costs, reducing stress on infrastructure, urban cooling, increased biodiversity, and improvement of the environment. One of the greatest benefits to having a green roof is its ability to manage water. The soil and vegetation on green roofs retain water from rain and snowfall, slowing the passage of precipitation into the city's stormwater system. Green roofs help to reduce the effects and potential damages caused by intense rainstorms and irregular snowbelts. Green roofs also help to make a better environment for people living in larger cities due to their ability to absorb sound, improve air quality, and help to reduce the effects of the urban heat island. The cooling effect of green roofs can also boost the productivity of solar panels, as their efficiency depends very heavily on the surrounding air having a lower ambient temperature. Green roofs can also be incredibly valuable for increasing biodiversity and wildlife in urban areas. Habitats that have been destroyed due to urbanization can be recreated along city skylines, attracting insects and birds by providing a source of food, water, and shelter. Because of the microclimate that can be created on green roofs, native species can flourish in an area that was previously uninhabitable. There are three main types of green roofs, each with its own benefits, challenges, and special design elements. The types of green roofs range from simple, extensive green roofs to slightly more complex, semi-intensive green roofs to very intricate and complicated intensive green roofs. As green roofs become more complicated, more varieties of plants can be utilized in their design. However, this also means more thought needs to be given in the many regulations for building safe and long-lasting green roofs. Building any sort of green roof involves a large amount of planning and the right type of green roof design so the green roof is suited to the structure it is being constructed on. Intensive style green roofs can support the life of many different plants and provide a sanctuary for urban wildlife and people alike. However, the building these green roofs are built upon require a great deal of reinforcement to support the huge mass of soil and plants that go along with these designs. This more complex design makes it almost impossible to retrofit into existing structures, and require a great deal of engineering to eliminate the possibility of failure. On the other hand, extensive designs make green roofs possible for almost any type of building, as they are lightweight and simple to install and maintain. They provide many of the same benefits as a traditional intensive green roof, but only require up to a quarter of the amount of growing media. This simple, bare-bones approach must involve a more specialized plant selection, as these plants must be able to flourish in as little as 2 inches of media and minimal nutrients, along with high winds, dry conditions, and huge temperature fluctuations. In some areas, the lack of growing media can actually complicate things, as this design does not provide a great amount of protection for the delicate root systems in extremely cold weather conditions. Semi-intensive green roofs can be a happy medium between the two of the varieties of green roofs. While there is a thicker layer of soil to protect plants from the extreme weather conditions, woody trees and shrubs are not generally part of the design. The plants used in semi-intensive green roofs have less substantial root system and require less media to grow in. In this way, semi-intensive green roofs don't require as much reinforcements as intensive green roofs, making they can still be used on existing structures.
No matter the type of green roof to be built, many of their design features are the same. For example, there will always need to be a layer of material at the base of the system that is 100% waterproof. Typically a plastic or synthetic rubber, it is used to ensure no water damage to the structure occurs. Failure to install this layer correctly will result in the entire green roof being removed to fix the leak, so it is important to install this layer properly. Next, there should be a layer of insulation to ensure that the full thermal insulation capacity is met and that the roots of the plant are protected. After that, there should be a layer of hard inorganic material such as PVC plastic to protect the building from the roots of the plants. This is especially important in intensive systems as they often involve many woody species with strong voracious roots. Next, a layer intended for water drainage is required, especially on flat roofs because standing water can be detrimental to the health of the plants. This is typically a thick layer of porous material accessed from the surface through drains. After this, a root permeable filter layer must be installed to prevent the growing media mixing with the drainage layer, causing clogs in the drainage system. Finally, the growing media must be installed at the top, which in an intensive system is typically a thick layer of up to 30 inches deep or more. On an extensive system, however, this layer can be anywhere from 2 to 8 inches deep, and must be lightweight and resistant to wind erosion and compaction. These complications limit the selection of potential medias to mostly inorganic materials such as pumice, expanded slate, clay, and shale. Each layer is very important to the success of the green roof, so great care should be taken when laying each layer. Green roofs and living spaces are used for many different reasons, and while green roofs have become quite the trend to follow, each green space is designed with something specific in mind, whether it be for entertaining, dining, or relaxation. Some designs come from inspiration, whether it be from nature itself or something personal to the designer of the living roof. Shape and pattern are two major factors to consider when selecting materials for green roofs. From plant selection to rock work, incorporating these factors into design creates responses by employing color, texture, and movement varieties. Contrasting colors and textures offers broad streaks of subtle color changes with textural variances. The selection of sweeping plant materials such as tall ornamental grasses creates a movement in the space and adds winter interest. This design concept helps to move the viewer's eye across the garden. Specific plant and material selection for intensive green roofs should be chosen with a few considerations in mind, such as potential drought tolerance, heat and freeze survival, maintenance requirements, and substrate depth. Plant selection. Plant material depends on the location of the green roof being built. The one we visited in Red Deer consisted mainly of native species to that area. Wider varieties of plant species can be used as long as they can survive the elements of the location they are being planted in. Three main factors are taken into account when it comes to plant selection, such as color, texture, and movement. While plant material may be the main source of color, as we saw at Berry Architecture and Associates, objects such as a bright red canoe can also make a visual impact, especially in the white of winter. Texture creates a unique look while still able to look uniform, and for those green roofs with little water supply, hardscaping materials such as rocks and gravel can be the solution, all the while creating textural varieties. Movement in design can create a sense of freedom for the viewer, while design elements can also lead the viewer's eye through the entire design, from one place to another. There are many regulations and guidelines surrounding the building and maintenance of green roofs. When designing a green roof, there is a long list of guidelines to consider so that the design doesn't fail. At best, failure would mean the death of the plants on the roof, but at worst it could mean the collapse of the roof and injury to people on top of or inside the building. The first consideration in designing the roof is the extra weight green roofs can add. Media, plants, hardscaping material, and equipment all can add a significant weight to the roof. Knowing the load-bearing capacity of a roof is crucial to designing a safe green roof. Design must accommodate the added weight of all materials and tools being used to build the green roof, the wet weight of the media when fully saturated, weight added by snow in the winter, and weight of the plants as they grow larger and spread. If the roof is to be used as a recreational space, the added weight of people needs to be taken into account as well. Builders must also be careful not to crowd equipment and materials in one area on the roof instead of distributing the load across the roof. Other considerations when designing a green roof are the effects of the wind and heat on the roof. Windy conditions can create problems if too much media is exposed on the roof or if the media is too light. Taller structures and plants can also be knocked over by wind, so it is important that these are secured. The high heat on roofs can also cause media and plants to dry out quickly, so it is important to have an irrigation system in place for times of drought. Other things to consider when designing green roofs are fire and safety regulations surrounding the height of the green roof, as well as the importance of designing for resistance to root penetration into infrastructure. Some of the best standards for green roof design come from Green Roofs for Healthy Cities, the authority on green roof construction. Their website has a long list of standards that are important to look through while designing a safe green roof. As our cities are slowly but surely expanding, we need to begin to make more of an effort to maintain the amount of plants we have, as they serve us in many ways. Green roofs are a way of ensuring that these plants, insects, and other wildlife have a home in our urban climate. Also, as the climate continues to warm, we will have more and more of a need for plant life to cool not only the cities they reside in, but the earth as a whole. Furthermore, as water supplies become more scarce with the increase in population, we will have an increased need for plants to filter and hold water. Energy is also a concern as we begin to try and reduce our carbon footprint, and green roofs have many proven benefits towards minimizing energy consumption as well as providing longer life to building materials. When used in conjunction with solar panels, green roofs increase the efficiency of the panels, increasing the renewable energy produced from each panel. Lastly, they provide green space for people living in the city that have minimal access to nature and provide beautiful scenery for people working and living in urban areas.